Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the medium problem. The problem name is combination sum. Its index is 39, and yes, it is the 17th problem of the daily LeetCode challenge for the month of February, right? Okay, so this problem totally involves the concept of backtracking, and like you need to consider every combinations, and while you backtrack and find all the solutions, you need to write down the code, write down the criterias efficiently. Like you need to mention some conditions so that you can improve the time complexity, so that it doesn't go in the worst case, like your entire solution will get a TLE verdict if you doesn't write down the conditions efficiently, right? So we will discuss all those. For now, let's understand the problem statement. Given an array of distinct integers, candidates, and a target integer target. So the important thing that is being noticeable over here is the distinct integers. We will be given some distinct integers and the target integer also target, that is we want to reach that target value, and we have to return a list of all unique combinations. Note that we need to return the unique combination of candidates that is being chosen from the input data, where the chosen numbers, that is the numbers we are going to choose, is going to sum up to a target value that would be given to us. You may return the combinations in any order, but that combination should be unique. The same number may be chosen from the candidates like in an unlimited number of times, and two combinations are unique if the frequency of at least one of the chosen numbers is different. Like some number x is chosen y times, and let's consider another combination where the same number x and all of the numbers are already same is chosen some z times, then y should not be equal to z, then only we can say this is going to be unique combination. If you're not going to understand this, no need to worry about, we will discuss all those in detail. Okay, so it is guaranteed that the number of unique combinations that sum up to the target is less than 150 for the given input. Okay, so yeah. Okay, so we'll be discussing the examples. Like first example that is quite helpful, and yes, we would be figuring it out what could be the best solution for this problem statement. Okay, so let's look over the constraints. The maximum size is going to be 30, that is the input data, and the values is going to be like 200, and all elements of candidates are distinct. That is going to be quite useful because yeah, that would improve our runtime also. And the target is going to be less than equal to 500. Okay, also yeah, if you're done with this problem like combination sum, I would strictly recommend you go to do this one, combination sum second and combination sum third. Also you can try this one also, letter combinations of a four number. This is actually awesome problem. Yeah, I've also solved that already, and the same video is also uploaded in this playlist also, April challenge 2021. You can see letter combinations of a phone number. It's 17 index, and it's day 8 of the April challenge for the previous year. If you're going to get the doubts over here, then you can visit this LeetCode April challenge 2021 playlist present over my channel, and you can look out for that video. Okay, so for now, let's focus over this problem, how we can use the concept of backtracking to find out all the solutions efficiently. Okay, so let's understand this problem. So we would be given the array 2, 3, 6, 7, and we have this target value. Okay, target is 7. Okay, now let's first understand what is the concept of unique combination. Suppose we have this number 2, 2, 3. Okay, let's for now forget this target and forget this array. Okay, and suppose we have this combination set which is included in our answer, and let's say we have another set where we are doing the elements, let's say is of the form 3, 2, 2. Now these two combinations are actually equal because you can see when we find out the frequency of all the elements, 2 occurs over 2 times and 3 occurs over 1 time, and in this also 2 occurs over 2 times and 3 occurs over 1 time. So you can see the frequencies are exactly matching, so this is actually the same combination. If any of the frequency is not matching, then the combination is going to be different. Okay, so this is all about the unique combinations. So let's understand how we can solve this problem efficiently. Okay, now also same number can be used any number of times. Let's say x times. This number also can be used y times. This number also can be used z times, and this one also is some w times. Okay, so the main concept of backtracking is what? We are going to choose some element. We choose some element, let's say array of I, a of I. So when we choose this element, let's say a of I, then you can see the target that we want to achieve, which is actually the sum of the chosen numbers, must be decreased by this value ai. Okay, so when we are done with this ai, that is we have already chosen this element, then we will try to choose some another element also, such that this target, that is this is my new remaining sum will reach 0 as soon as possible. Not calling it as like reaching the target value quite quicker, but rather than we need to check out all the combinations. Okay, so when we choose some element, let's say ai, you can see the remaining sum would become target minus ai. Okay, now when we are done with this choosing one, then we will again perform the recursion on the remaining set. Not calling it remaining set, remaining sum remaining sum, and we have again the same set size, which is actually 2 3 6 7. And you can see we will also pass one more data, the set of chosen numbers. And you can see when we are done choosing its ai, let's call this ai value as 2. So you can see set of chosen numbers is now 2, and then again we will reach to another state where our new target is remaining sum, and again we have the same set 2 3 6 7, and up to this state we have chosen the numbers only 2, and we are going to do the same operations again. Okay, so let's take an example and frame it out how this is going to be possible. Okay, so what I'm going to do is, like, let's say we have chosen this for the current state, we have this target as, let's call this t as 7, and we have the set 2 3 6 7. Okay, and you can see the set of chosen numbers up to this state is exactly an empty set. Okay, now let's say we are going to move further. Let's say we have chosen this number 2. When we have chosen this number 2, you can see target becomes 5, and the next state that we are going to reach is again 2 3 6 7. Note that you are not going to eliminate this 2 like by saying that yes we have chosen this 2, because we can choose the same number any number of times, as you can see there is a statement unlimited number of times. Okay, you can see, and the next state we are going to have the target value as 5, because we have chosen the number 2, and so the target will be reduced by 2, and the set of chosen numbers is 2. Okay, now you can also move out to the next position, like you are, like in the previous case you have chosen this number 2, but you are going to choose this number 3. So when you are going to choose this number 3, target becomes 7 minus 3 4, and the set is again 2 3 6 7, and you can see set of chosen numbers is 3. Again you can also say you can choose 6, again you can also say you can choose 7, and so on you can have. So let me just show out you for the only one case, because that would make the recursion tree a very long, so that could be a time consuming. Okay, so for now over, let's consider only this case. Okay, so in the next case what we are going to do, we can choose this 2, we can choose this 3, we can choose this 6, or we can choose this 7. There are again many possibilities. So let's say we have chosen again this 2, so target becomes 3, and we have the set 2 3 6 7, and we are going to have a set of chosen numbers as 2 and 2. Again we are going to move out to the next state. Note that if we choose 2, target becomes 1, and again if we choose 2, target becomes minus 1. Note that we need the target to be exactly 0, so we are not going to choose 2 over here right now, rather than we will backtrack, and in the previous level we will come over here and choose 3, right? So when we choose 3, target becomes exactly 0, and the set is 2 3 6 7, and the set of chosen numbers is 2 2 and 3. Now here is the very complex case. You can see you have achieved a state where the target becomes 0, and this is the set of chosen numbers that will give you the sum exactly equal to the target, which is 7. Okay, sum of chosen numbers is 7. You can see 3 plus 2 plus 2, which is 7. Yeah, so yeah, this is one of your answers. Okay, what about some more answers? Can you get some different answers? How you are going to get that? Okay, so in that case also, suppose this is one of your answers, then and the current step you have chosen the element 3, right? So in the next step what you are going to do is you are going to pop out this 3 and insert the 6. When you insert the 6, your set becomes 2, 2 and 6, but this value is going to be greater than target, which is greater than 7, so you cannot append this 6 and move further, so you will discard this value. In the same way, you are going to backtrack to the each of the elements and find out all the possibilities such that the chosen number sum will match to the target. This is called the backtracking. You need to consider every possible state, and if this is an optimal state, then you should move further. If this state is already wrong, then you should backtrack and choose some another number. Right? Okay, so let's talk about the time complexity first. Okay, so the time complexity, in the general case, in a backtracking, we can say the time complexity is 2 raised to the power n. Like for the general case, it's if you're solving some problems, then the first concept that strikes in your mind about the time complexity, yes, there will be an exponential complexity, and it should be 2 raised to the power n, right? But here also you can see this is not like time complexity should not be a 2 raised to the power n, but to be a like to find out the upper bound of this complexity would be like something. You can see there are n candidates, and you can see for if you calculate the depth of the recursion tree, like the maximum depth of the recursion tree, let me talk about max depth. So for finding out the max depth of the recursion tree, so this is our target value, and if you divide it by the minimum array of I value, which is the candidate of I, if you divide it by minimum array of I, this is your max depth. So your complexity for upper bound complexity would be n raised to the power, let's say this value is x, so n raised to the power x is your time complexity. So we can say that this is the upper bound of the time complexity, right? Okay, so let's move out to the code to implement that. Also, I have done a breadth first search approach, like you can call it as BFS, to find out all the possible combinations by tracking the unique set combinations. You can do that. Okay, so I will show out both the codes. Let's try to understand that. Okay, so you can see my first code was this one, 97 ms, right? Okay, so I think I should have to show the second one. It doesn't make some difference because only thing I have done quite difficult is like taking some sum as well as the corresponding vector that is giving this sum. But this one should be quite easy for you to understand because I've written a commented code so that it would be easy for you. So we can start with a empty vector. Note that this is a BFS based approach. I will also show you how the backtracking is also going to be involved over here. So we will start with an empty vector and we will find out every unique combinations. So set is going to store the whether this combination has been reached or not. Okay, so we will pop out the current vector and find out the sum first. Okay, so this function, this accumulate this vector, if you are familiar with this one in C++, then you are going to get the sum. So if this sum matches with the target, then this is one of the combinations that we can have. So we will push back into our answer. Okay, so let's find out other combinations. So we will again start traversing in this candidates and we will check it out if we can append this num or not. If current sum plus num is still less than or equal to target, then we can include this number into the set of the current chosen numbers. So we will make a new vector and push back this number into our new vector. Okay, and how to check that this set is visited or not? Note that this visited set of vectors is also always going to track the visited set of chosen numbers or not. So we will first sort it and check it out. So to match the frequencies is yeah, you can take those hash table to match those frequencies, whether the same like we have some chosen set of numbers and then we have some again chosen set of numbers and these two set are exactly equal or not, then you can match their frequencies. But there is one more way we can do that, which is sort these two vectors of chosen set and compare the elements. If they are exactly equal, then we can say this set is a repetition of the current set. Okay, so we'll sort it and check it out if this vector, new vector, has an entry in our visited set or not. If it is not, then we can insert it and push it into the queue. Okay, in that case, we will also get correct answers, but runtime is not so good. So we can use backtracking to find out all the possible sets. Okay. Note that worst case time complexity goes to n raised to the power target divided by minimum of the input data. So, okay, so let's define an answer globally over here. Answer dot clear for every test case we can do that. Yeah, and first of all we sort the candidates because yeah, that would help me to improve the complexity because first smaller number should be checked it out. It doesn't matter. I think sorting would make quite much difference. Okay, so let us uh, do that. We can check it out first whether sorting makes the difference or not. Let's uh, comment this one and submit. Okay, so I've run this code by mistake. Let's submit this code and check it out whether the runtime. Yeah, that's good. You can see we can have the improved runtime over here. Okay, so let's understand this one. It doesn't make any sense because you're always going to choose some of the elements, whether it is in sorted form or not sorted form, because you have a distinct integers. Suppose we have the integers having the same type, like we can have a duplicates also. In that case, sorting makes sense because we need to skip the duplicates combinations efficiently. Okay. So start with the position 0, target and candidates and the current set of chosen elements. So if the remaining sum becomes strictly negative, we are going to return, that is we are not going to get any valid combinations. If the remaining sum is exactly 0, we will push back our current set of chosen numbers into our answer. This is a valid combination and we will start with the current position and goes up to the entire input data, and we'll first push back this candidates of I. Let's say we have chosen this number. So when we have chosen this number, remaining sum becomes like it decreases by this amount, remaining sum minus, like the new value is remaining sum minus candidates of I. Okay, and candidates and current set. Okay, note that we are passing this I over here, like the new position is again I because we can choose the same element multiple times. Okay, and yeah, since we are use a concept of backtracking, this choosing this number has been done, so we will pop out from the current set of chosen numbers and then backtrack for the next possible numbers, right? Like we are going to check every case and that will give you the valid combination. So this will give you all test cases passed. So if you guys have still any doubts regarding anything, you can tell me in the comment section of the video, and thank you for watching this video and do not forget to subscribe.